Yeah, welcome to the class, my dear students. In the last lecture, I have done the improper integrals of type 1. That means the intervals, whatever the integral limits are infinity, minus infinity or plus infinity, how to solve those type of problems I have explained in the last class. Now, I am explaining in this lecture about the improper integrals of type 2. So, let us now see the problem, how it is. Now look at the problem. It is type 2 means integral 0 to 3 dx over square root of 9 minus x square. So here it is very clear that the function is not defined. That means the function becomes infinity at the point 3. That means when you substitute at x equal to 3, it becomes 9 minus 9 and it is 0. And whenever there is 0 in the denominator, the function is not defined at that particular point. That means at x equal to 3 it is not defined. So in such a case, how to solve this type of problems now we are doing. So first of all, you have to say that it's of type 2 improper integrals. First you have to identify that and then you have to start the integration. So how we do? We write this as limit. Now whenever the lower limit, if you are getting as infinity, that means suppose if you put 0 as infinity, you will be putting the limit as lower limit as a. If the upper limit, if you get as 0 suppose in the denominator, then you have to get b, write b as the upper limit. So the lower limit will be as it is. Now what is this b? B is going to the limit value 3. So now 3 minus we write. Why? Because when you b goes to 3, the value becomes infinity. So just we write the left hand limit of 3. That means 3 minus we write. So that is given by dx over square root of 9 minus x square. So now I hope all of you know what is the integral of dx over square root of 1 minus x square or a square minus x square actually. When you write this, this is given by sine inverse of x by a is the formula. It is given by sine inverse of x by a. Dx over square root of a square minus x square is given by sine inverse of x by a. That's the formula. So now we write what is this here? This is given by limit b tends to 3 minus. Now what is the integral of the value is sine inverse of. Now in the place of 9 actually how can you write this as? This as 3 square. So in the place of a you have 3, correct? So it is sine inverse of x by 3. So that gives, and now put the limits from 0 to b. Okay. So now what is the solution for this? It is limit b tends to 3 minus sine inverse of, now how to apply the, as how we have done in the definite integrals, sine inverse of b by 3 minus upper limit minus the lower limit is sine inverse of 0. Now substitute as limit b tends to 3 minus b sine b by 3. So what we can do directly, we can substitute the limit as b tends to 3. It becomes what? Sine inverse of 3 by 3 which is 1. Okay. And minus sine inverse of 0. Now how to find out the values of sine inverse of 1 and sine inverse of 0? As we know, sine pi by 2 is 1. What is pi by 2? Is given by sine inverse of 1. So you have to remember this one. Similarly, sine 0 is 0. So what is 0? Sine inverse of 0. So this is what the values we have to write. So now what is sine inverse of 1? The value is pi by 2. Sine 0 is 0. So therefore the value of this improper integral has become now pi by 2. So this is the solution. So this is the first problem. Now let us go to the second problem now. Suppose we have, let us take one problem like this. Integral of 1 to 0 dx over root x. So again, here it is clear that it is of type 2 because at what point the function is undefined, that means at what point it becomes infinity? At the point 0. That means if you put 0 here, it becomes 1 by 0. So that means it is infinity. So the function is undefined at the point x equal to 0. So the upper limit only here also. So what we can do? We write this as limit. Now what is the first lower limit is 1, upper limit is 0. So what we can write always as minus integral of 0 to 1. Okay. I hope all of you remember what is integral a to b f of x dx always can be written as negative integral b to a f of x dx. That means if you interchange the limits, it is negative. Because the limit here is the negative value, the 1 to 0 is there, we cannot write from 1 to 0, right? 0 to 1. So we are putting the negative value here. So it is, now if you observe, the value here is limit minus of integral 0 to 1 dx over root x. But here, what is the, when you put the lower limit only now, it becomes a 0. So how can we write this as? We write this as a, and a goes to 0 minus. A goes to 0 minus. Why? Because at the point 0 it is infinity, so we put that 0 minus. That means the left hand limit of 0 gives you the value of a. Now let us solve this integral. That is limit a tends to 0 minus negative integral of a to 1 x to the power of minus half dx. Now what is this value? It is limit a tends to 0 minus what is integral x power minus half? X power minus half plus 1 over minus half plus 1. Now put the limits from a to 1. So what it gives you now? That it gives you the limit as limit a tends to 0 minus, it is negative of, when I apply the upper limit, now it is x power 1 minus half becomes, flip the fraction, which gives you to x power half within the limits a to 1. And now that gives you the value as limit a tends to 0 minus, the value is minus. When you apply the upper limit, it becomes 2. And when you apply the lower limit, it becomes 2a. So now as a goes to 0, the value is what? This whole thing, this value gives you as a tends to 0, this value goes to 0. So you will be remain with only minus 2. So the value of the limit is now minus 2. So this is what the solution. The value of the limit is given by negative 2. This is what the solution for the given problem. So like this we can solve the improper integrals of type 2. Thank you.